Hello guys, as I promised, I'm going to show you how I would do it, and I have done it. I have done it one more time before I do this recording. Um, because you understand, I'm not going to test you on this, and I'm not going to quiz you on this either. It's just a practice of algebraic, practice. So you can just sit and relax and follow me and to go through this. Maybe you have better idea to handle this algebra. Okay, so this is the question we did in class. And the first order derivative, we follow the quotient rule, which we differentiate the numerator and multiply the denominator, differentiating the denominator, and then multiply the numerator and square the denominator. Okay. All right. Now let's make some space. Okay, the derivative of x squared is 2x, and 1 plus e to the power x. The derivative of 1 plus e to the power x, the derivative of 1 is 0, the derivative e to the power x is e to the power x. We got these. We did one approach in class that was, we're gonna differentiate this entire numerator. But on the hand side, I thought of another way to differentiate, which I separate. Okay. So now we already got the answer. The answer to the first order derivative is already is right here. It's right here. However, looking ahead, because we're going to differentiate the first order derivative to get the second order derivative, I was thinking maybe I can partially, make this whole thing into two pieces and apply the quotient rule separately to make it easier. Easier meaning not too complicated, to avoid certain mistakes. All right. So I take this piece, divide into that. As an algebraic practice, I just want to show you this piece divided into that. We got this piece, and that same denominator divided into the second part, and we got this piece, which is a minus. And 1 plus e to the power x will take away the 1 plus e to the power x in the denominator. So the derivative, the first order derivative, can be expressed either this way or this way. I'm going to use this latter one to do second order derivative, right? And meanwhile, of course, the answer to the first order derivative is already done. Second order derivative. Second order derivative is a derivative of first order derivative. So the first order derivative, we use this form, which is from here, right? We just showed you how to do that. So we, instead of differentiating a one big quotient, we differentiate two smaller quotients. So differentiating the first one, differentiating the second one. When we are differentiating the first one, I took the 2 out. So 2 is factored out. So I'm differentiating a simpler, form. On the other one, this is just as simple as it can get. Okay. Quotient rule is applied. Differentiating the numerator, multiply the denominator, subtracting numerator, multiply the derivative of the denominator. And we do the same for the second part, which is square the denominator. Well, we had the square denominator here. Square the denominator, so 2 being squared, power 2 being squared again is power 4. Differentiating the numerator, okay. Keep the denominator, and differentiating the denominator and keep the numerator. So we're doing two quotient rule okay, in one line. On the first part, we got derivative of x is 1, right? 1 times 1 plus e to the power x, so we get a 1 plus e to the power x. And this latter part, the derivative of 1 plus e to the power x is e to the power x. So we got this piece. And on the next piece, the derivative of x squared times e to the power x, this is going to be product rule. Product rule, so differentiating x squared, right? And 2x e to the power x, and x squared derivative e to the power x. So this is the result of a product rule on that derivative. Denominator stay the same, minus, and we're differentiating the denominator. Well, remember we have not learned chain rule, so we're not going to apply chain rule yet. So this, to differentiate this piece, we're going to differentiate, we're going to, make expand the squares. So 1 plus 2 times e to the power x plus e to the power x times e to the power x. So this is basically e to the power x. Okay, there's a couple forms I'm going to show you. You can write it this way. You can also write it this way. Okay, and then 2 times x, and that's going to give us e to the power of 2x. But because we haven't learned product chain rule, and in order to differentiate e to the power 2x, so we're going to split it as x plus x, right? And that's going to be e to the power x times e to the power x. That's why we keep this form, because we are preparing ourselves to use the product rule. Okay, so the product rule is done here. So on the next step, right, everything else almost unchanged. We just take the 2, multiply the numerator in every term. So 2 times 1, 2 times e to the power x, 2 times 2, 2 times x times e to the power x. So this part is done. We're not going to do anything to this part for a while. We're focusing on this piece. All right, we're done the product rule. Right? So it's better we keep it at the parentheses. So we don't really need that bracket. So just like that. And differentiating this bracket, the derivative of 1 is 0. The derivative 2 times e to the power x is e to the power x. Plus, okay, so we're differentiating that piece, which is the product rule. And after we apply the product rule, the derivative e to the power x is e to the power x. So we get e to the power 2x plus e to the power 2x. So that's 2 times e to the power 2x. That's why we got here. And on the next step, nothing else changed. Okay, we didn't change anything here. Nothing changed. We only have factored out e to the power x from this bracket. So we get a 1 plus e to the power x. The 2 is factored out, it's placed in the front. And now we have 1 plus e to the power x, 1 plus e to the power x squared. So now we can reduce 1 plus e to the power x. So on the next step, they stay the same. This become power 3, and 1 plus e to the power is gone. And there were 2, 1 plus e to the power x squared, so we have 1 more left. We came to this point. On this step, we are making common denominator. The common denominator is 1 plus e to the power x to the power 3. We got the power 3 here, but we don't have it there, so we have that piece, right? That's 1. Now we have the same denominator, but looking ahead, we notice that this piece and that piece has a common denominator, has a common factor, which is 1 plus e to the power x. Okay, so I'm taking, because they have the same denominator, so I take this piece, subtract this piece. Okay, so we got here. Then you say, how about the other part? The other part, I still keep them separated, but this is a negative. There's a negative here, so it's a plus. Okay. And next, I'm factoring out this piece. So 1 plus e to the power x is factored out. So what's left in these two parentheses, they are going to be combined. They are combined, and they combine into this piece. Okay, you can see there's some like terms, right? 2 times e to the power x, no like term. 2 has no like term. X squared e to the power x, no. These two were like terms, and their minus is a minus 4. Okay? Now, shall we go further? We could. Okay, we could go further. To go further, we would take this piece, multiply that piece. Okay, so this piece, multiply 1 plus e to the power x. So we want to combine them into one single expression. Okay, so then you just do product, do FOIL. This is a big FOIL. Okay, so 1 times that, 1 times this, 1 times this, and 1 times 2. So 1 times all of these, we got all of these. Okay, plus e to the power x times each one of them. Okay, so e to the power x times each one of them. So this one gets to multiply e to the power x times that, times that, times that, times that. Are there room to combine? Okay, are there room to combine? Yeah, we can. This piece, that will make e to the power 2x. E to the power 2x. E to the power 2x. Do we have any like term in front? No. And this will be another e to the power 2x. Right? Gone. And this will be another e to the power 2x. And that's it. But this 2 times e to the power 2x, e to the power x will combine with that, the first one. Okay, so on the next line, we combine these, this one with that one, which is going to be a 4. Okay, so that piece combined with that piece. X squared e to the power x. Do we have another x squared e to the power x? No. 4x e to the power x. 4x e to the power of x. We have 4x e to the power 2x. No, there's no like terms, right? 2 is standing alone, right? This piece, okay? And 2 times e to the power 2x, I don't see any more like terms. So how many? 3, 7, 4, 5, 6, 7. So we got 7 terms. And this will be arranged according to their degree. But you can keep this one. Okay, this is the result is that is multiply this piece with that and adding, we're going to be adding another one. Okay, so the next step. So it's really useful to have a scratch paper on the side, right? So this piece is turning into denominator stay the same. Numerator is this guy. And plus this whole thing. And last but not least, and of course, we're gonna add this piece to the total, right? When we add this piece to the total, right? We don't need this anymore, so now we're adding this piece. Where does this, what this term combine with? Not this one, not this one, not this one, not this one. It looks like it's this one, right? It's a positive 2, this is a minus, so this is gonna be plus. So in the end, we get that. So in the end, okay, in the end, we get this piece. It's pretty hard to make it into factor form, even though we can try. Right? You can regroup, but I'm pretty happy with this. I'm pretty happy with this result. Okay, you can rearrange it. How many terms we have on the top? But this serves as an algebraic practice, If you're interested in, we want to enhance your algebra and, improve your algebra, then you can try it. Okay, it's a good practice. It's even a good practice for me. Well, thank you for watching.